Okay, so again, we're working in section 1.2 of the Developmental 2 class notes by Al Grosha. This time we're going to talk about fractions. What is a fraction and why do we need them? So we got a few definitions here at the top. Factorization is the process of expressing a number as a product of two or more numbers, and you can see some examples of factorization here. When we express 24 as a product of 2 times 2 times 2 times 3, it's called factorization. Here's some different kinds of numbers. We have prime numbers and composite numbers, or composite. It doesn't really matter how you pronounce it. A prime number is a whole number that's greater than 1 that has the factors only 1 in itself. In other words, it can only be evenly divided by 1 and itself. And here we have a list of the first 10 prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. They can only be evenly divided by themselves and 1. A composite number, on the other hand, is any number greater than 1 that's not prime. So these are the numbers that have more factors than 1 in themselves, the composite numbers. Prime factorization, every composite number can be factored into the product of 2 or more prime numbers. So here we have an example of prime factorization, and this looks a little strange, but this is kind of like what you guys might have learned as the tree. When you prime factor a number, we start with the number at the top, and then we draw 2 little branches, and underneath those branches we write any 2 numbers that multiply. 21 times 10 multiplies to make the 210. So we're breaking apart the 210. And then we're asking ourselves, are these prime numbers? Well, no, 21 is not a prime number because I know 21 also has the factors 7 and 3. And 10 also has the factors 2 and 5. And now we're down to prime numbers down here. And these numbers are the prime factorization of 210. The prime factors 2, 3, 5, 7. And we have them in a different order, but it doesn't matter what order you write them in. So we're going to do some practice examples here. We're going to find the prime factorization of 256. And I'm going to enlarge this so that we have room to do the tree here. So let's see, if we write 256, we need 2 numbers that multiply to make 256. So let's see, well, right off the bat, I know 2 times what? 2 times 100, pen's not working, 128. And then we're asking ourselves, are either one of these prime numbers? Well, I know that 2 is a prime number, so I don't have to break the 2 down any further. But I know 128 is not. So 128 is also 2 times 64. Well, again, 2 is a prime number, but 64 is not. So I know that 64 is 8 times 8, which are neither one prime numbers, so I'm breaking them down again. 8 is 4 times 2. There's another 2 there. And 4 is 2 times 2. And we're going to do the same thing over here. 4 times 2. I'm circling all my 2's because those are all prime. And 2 times 2. We have a lot of 2's here. So when we get ready to write 256, I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So I can write that as 256 equals 1, 2, 3, 4, 5, 6, 7, 8, or 2 to the 8th power. If you don't remember the exponents, it's fine. We're going to go over exponents here in a little bit. So let's do it again. Let's find the prime factorization of 189. So we have 189. Well, this time 189 is not divisible by 2, but it is divisible by 3. That's 3 times 63. 3 is prime. 63 is 7 times 9. 7 is prime. And 9 is 3 times 3, and they are both prime. So 189 equals 3 times 3 times 3 times 7. If you want to write it with exponents, we would write 3 to the third power times 7. And again, don't stress the exponents because we're going to talk about them in a later section. All right, what's the meaning of a fraction? Here we have the fraction 1/2. It has three parts. The numerator is the 1, the fraction bar, and the denominator, which is 2. The denominator means whatever I had, whether it was a pie or a pizza, it was divided into this many parts, equal parts, 2 pieces. And the numerator means how many I'm counting. So when I say I ate 1/2, that means I ate 1 out of the 2 equal parts. So there's some special forms of fractions here. Any fraction that's the same on the top and the bottom equals 1, even if they are letters, variables. A over A equals 1. 5 over 5 equals 1. 1,000 over 1,000 equals 1. Any fraction that has 1 on the bottom is equal to whatever the numerator is. A divided by 1 is A. 7 divided by 1 is 7. 256 divided by 1 is 256. Any fraction that has 0 on the top is equal to 0. 0 divided by A, 0 divided by 9, 0 divided by 34, all equals 0. Any fraction that has 0 in the denominator is undefined. It doesn't matter whether it's a variable in the numerator or a number, a 0 in the denominator makes a fraction undefined. So these two right here are the two that everyone seems to get confused. When there's a 0 in the numerator, the fraction is equal to 0, but when there's a 0 in the denominator, the fraction is undefined. So this is an example of reducing fractions using prime factorization. This is convenient when you have big numbers in your fraction, but a lot of people know faster ways to do this. A quick way to do this is to divide the numerator and the denominator of the fraction by a factor that they're both divisible by. 30 and 36 are both divisible by 6. If you divide the numerator and the denominator both by 6, 30 divided by 6 is 5, 36 divided by 6 is 6. You get there quickly. But you can use prime factors like this, and this is useful with variables also, and also big numbers. You can just break up your number. 30 is 2 times 3 times 5, and 36 is 2 times 2 times 3 times 3. And then you cancel the factors that are the same in the numerator and the denominator, and you've reduced it down like that. So we're going to practice reducing a little bit. If we reduce 12 over 18, we can divide both of those by 6. They're both divisible by 6. We get 2 over 3. 33 over 40. If you know these numbers, you will see that 33 is 3 times 11, and 40 is 2 times 2 times 2 times 5, and there are no common factors. So 33 over 40 is already reduced because there are no common factors that can reduce there. 24 over 56. Again, these are both divisible by 8, so you can reduce by dividing them both by 8. Or you could write out the prime factors and reduce that way if you like. 63 over 42, these are both divisible by 7. So when you reduce this, you'll get 9 over 6. But look, 9 and 6 are also divisible both by 3. So you can divide this again. Let's divide these both by 3 now. And what do you get? 3 over 2. And that will be the final reduced form of that fraction. So now we're going to talk about mixed numbers. A mixed number is simply the process of writing a whole number and a fraction together. 5 and 3/4 is a mixed number. There's a whole number and a fraction. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. So 23/4 is an improper fraction. We're going to convert between mixed numbers and improper fractions. The process for converting a mixed number to an improper fraction is first to multiply the denominator times the whole number and then add the numerator. So 4 times 5 is 20, 20 plus 3 is 23, and that's your new numerator. The denominator always stays the same, so this becomes 23/4. So we can practice here a little bit. Multiply. 2 times 1 is 2, plus 1 is 3. That's the numerator. The denominator stays the same, so this is 3/2. Multiply. 3 times 3 is 9, plus 2 is 11. The denominator stays the same. So that's converting a mixed number to an improper fraction. To do it the other way, it's a division problem. This is really 23 divided by 4. So you could write it in the box like this. How many 4s are in 23? 5. 5 times 4 is 20. Subtract. You have your leftovers of 3, and that becomes the numerator. The remainder becomes the numerator. The divisor becomes the denominator. So this is 5 and 3/4. So it's a division. Some people can do this mentally without writing the box out. Some people like to write the box out. So we're going to do this mentally. How many 2's are in 7? So 2 goes into 7 3 times. That's the whole number. 3 times 2 is 6, so there's 1 left over. And the denominator always stays the same. So this is 3 1/2. 5 goes into 42 8 times. 5 times 8 is 40, so that means there's 2 left over, and the denominator stays the same. We're going to multiply fractions now. Remember to always simplify your answer at the end. To multiply fractions, you just multiply top times top, bottom times bottom. So 7 times 3 is 21. 8 times 5 is 40. 21/40. 21 and 40 have no common factors, so it's already reduced. So we're going to do these. 2 times 4 is 8. 3 times 5 is 15. 8 and 15 don't have any common factors. Let's go to number 2. 2 times 3 is 6. 5 times 4 is 20. This does have common factors. 6 and 20 have the common factor of 2. So we're going to divide, to reduce this fraction, divide the top and the bottom both by the same thing, and we get 3/10. All right, let's do number 3. There is a way to reduce these fractions before you multiply. If you remember, this is what we call cross-canceling. And you can look diagonally to see if there's any common factors. The 4 and the 8 have a common factor of 4. So when I divide them both by 4, this gives me a 1 and a 2. The 15 and the 3 both have a common factor of 3. So if I divide them both by 3, that gives me a 1 and a 5. It's just reducing before you multiply, and then you multiply the new numbers. 5 times 1 is 5. 2 times 1 is 2. This is called cross-canceling. Maybe we should write it here. Cross-cancel. It's just reducing before you multiply. If you don't like doing it, it's okay to multiply and then reduce the traditional way at the end. It's just this. I think this is a little bit easier because you're dealing with smaller numbers when you reduce. If you multiply these first, you're going to have 60/24, which of course are bigger numbers to try and multiply. So if you know how to cross-cancel, I would use the cross-canceling. It just makes reducing your fractions easier. Okay, so how do we multiply mixed numbers? And that's what these are, 1 1/2, 2 2/3. We have to first convert to improper fractions. So multiply and add gives us 2 plus 1 is 3, gives us 3 over 2 times 6, 7, 8 over 3. And I'm going to cross cancel because I see these can both be divided by 3, and these can both be divided by 2. And that gives me 1 times 4, 1 times 1. 4 over 1, which simplifies to make 4. All right, dividing fractions. Some of you guys know a trick for dividing fractions. You say skip, flip, multiply, copy, switch, and flip, whatever that shortcut is. You keep the first fraction. Keep, change to multiply, and then flip the second fraction. So you're going to keep the 1/7. You're going to change to multiply. You're going to flip the second fraction, and then you just multiply top times top, bottom times bottom. So keep, change to multiply, and flip. That's how we divide fractions. So we're going to try this one. We're going to keep, change to multiply, and flip. Before I multiply, I like to cross cancel, so I'm canceling the 2 with the 4. They're both divisible by 2, and that gives me 1 times 5, 3 times 2, or 5/6. On number 2, I'm going to keep the first fraction. I'm going to change to multiply, flip the second fraction. I'm looking for any cross canceling, but you look diagonally, the 2 and the 3 don't have any common factors. The 4 and the 5 don't have any common factors. So multiply 2 times 4, 5 times 3. And number 3, keep the first fraction, change to multiply, flip the second fraction. We can cross cancel. The 3 and the 15 are both divisible by 3. The 8 and the 2 are both divisible by 2. And then I can multiply 4 times 1 across the top, 5 times 1 across the bottom. All right, to divide mixed numbers, just like multiply, you have to first change them to improper fractions. So that will be the first step. Multiply and add. So 8 plus 3 is going to be 11 over 4. I'm keeping the divide for now. Multiply and add. So 33 over 5. And then I keep the first fraction. I change to multiply. I flip the second fraction. All right, it looks like the 11 and the 33 have a common factor of 11. So I can divide by 11. And then I multiply the new numbers. 1 times 5, 4 times 3. And I get 5/12. That's the bottom of the page. So this is adding and subtracting fractions this time. So the big thing to remember when you add and subtract fractions is they have to have the same denominator. So these two fractions have the same denominator, and my sum will also have the same denominator. All three of these numbers have to be the same when you add and subtract fractions. And then you just add or subtract to the numerator. So it's 2 plus 3 is 5. So this makes 5/7. So my denominator is 13. All three of these have to be the same. And then I just subtract 10 minus 4 is 6. Of course, the last step is always to make sure they're reduced. But 6 and 13 don't have any common factors. So this is reduced already. Those are usually pretty easy for students. The problem comes when we have fractions with different denominators. We have to find a least common denominator. Least common denominator is just the number that's the smallest number that's divisible by the two denominators that we're looking for. So this is kind of an example of a simple way to find a least common denominator. The directions here say first find the prime factorization. If I'm looking for a least common denominator for 10 and 28, I can find the prime factors, and then use each prime factor the greatest amount of times it appears in each number. So I just take the biggest group of each factor. For instance, I see some 2's here and here. Well, this is the bigger group, so I take this whole group. I take the biggest group of 5's and the biggest group of 7's, and when I multiply all that together, it gives me the least common denominator, or the least common multiple also, it's called. So we're going to practice finding the least common denominator of 15 and 20. So first, the prime factors of 15, 3 times 5. The prime factors of 20, 2 times 2 times 5. And if you use the tree on those numbers, that's what you get. So the least common denominator, the biggest group of 2's, the biggest group of 3's, and these 5's both have the same number in them, so it doesn't matter which group we take. When we multiply all of that together, what do we get? 60. So the least common denominator of 15 and 20 is 60. So let's do it again. The least common denominator. Okay. The prime factors of 8. 2 times 2 times 2. The prime factors of 12. 2 times 2 times 3. So the least common denominator, we'll take the biggest group of 2's, and the only other factor we see is this 3. You multiply all those together, you get 24. The least common denominator. Now, if you know your multiplication facts, you probably already knew the smallest number that 8 and 12 both divide into evenly is 24. So you don't always have to do this. If you know multiplication really well, you can do this mentally sometimes. But if you get stuck with numbers that you don't know, then this is a way to break it down and do it on paper. All right, so we're going to add and subtract fractions with unlike denominators since we just practiced getting a common denominator there. All right, so we have, I'm going to write 2/9 plus 7 over 21. They do not have the same denominator. So by process of finding a common denominator, we find the common denominator is 63. Now the big deal is changing the numerators, because if you change the denominator, you also have to change the numerator. So you just have to say to yourself, 9 times what makes the 63? We know that 9 times 7 makes 63, so we have to also multiply times 7 in the numerator. So the new numerator will be 2 times 7, which is 14. 21 times 3 gives us the 63, so we're going to multiply times 3 in the numerator. 7 times 3 gives us the 21. And now we can add. The denominators are both the same, so the denominator will be 63. When I add the numerators, I get 35. Well, 35 and 63 both have a common factor of 7. So if I divide them both by 7, I get 5 over 9. So that's the process of adding and subtracting. Let's do a few practices down here. All right, these already have the same denominator. So I know my denominator is going to be 7. When I add the numerators, I get 8 over 7. Now this is an improper fraction. In algebra, generally it's okay to leave your answer improper unless the directions tell you to write it as mixed. So let's just practice writing this as mixed. We would divide. 7 goes into 8 one time. That gives us 1 left over, and the denominator is going to stay the same. These two fractions don't have the same denominator, so I'm going to write them vertically. 6 over 15 minus 2 over 9. And I'm going to change the denominator. The smallest number that 9 and 15 both go into is 45. So we need a change now. 15 times what gives me 45? Well, 15 times 3 is 45. So in the numerator, 6 times 3, whatever you do to the denominator, you have to do to the top. That gives me an 18 here. 9 times 5 gives me 45. So 2 times 5 will give me 10. When I subtract, the denominator will be the same. I can subtract the numerators to give me 8 over 45. And 8 and 45 don't have any common factors. So we don't have to worry about reducing them. They're already reduced. All right, we're going to add some mixed numbers. So we have 5 and 3/10 plus 2 and 5/14. So we don't need to do anything with the whole numbers. I'm going to keep the whole numbers. We just need to change the denominators of these fractions. The smallest number that 10 and 14 go into is 70. So 10 times 7 makes 70. So 3 times 7 in the numerator is 21. 14 times 5 is 70. So 5 times 5 in the numerator gives us 25. And when we add these now, the denominator is going to be 70. 21 plus 25 is 46. And 5 plus 2 is 7. This is great, except 46 over 70 can be reduced. They're both divisible by 2. So when we divide them both by 2, the whole number is staying the same. 46 divided by 2, 70 divided by 2. And this is what we get fully reduced. All right, we're going to try number 4. If I'm not mistaken, if I remember correctly, this one's a challenge. We have 8 and 2/9 minus 7 and 2/3. So the first thing we notice is that we need to change the denominators. So the smallest number that 3 and 9 both go into is 9. So I don't need to change this one. All right. 3 times 3 makes 9. So 2 times 3 is 6. So this is where the challenge starts to come in, because this is subtraction. I can't subtract 6 from 2. So there's actually 2 ways to do this. A lot of people like to go ahead and turn these into mixed numbers, and that makes the subtraction easier, so I think we'll just do it that way. We'll turn these into mixed numbers. If you remember how to do that, you multiply the denominator times the whole number and then add the numerator. So 9 times 8 is 72, plus 2 is 74. So we have 74 over 9 minus, and then we do the bottom here, 9 times 7 is 63, plus 6 is 69 over 9. And now we can subtract these. So what do we get? The denominator is going to be 9. 74 minus 69 is 5. So we have 5/9. So that seems to be the fastest way to do that.